All right, so we got everything we need. We got the two charges. We have the distance between them. K is the same constant each time, 9 times 10 to the ninth, so that's the same. Excuse me. And we want the force between. So that is the equation that we learned. So electrical force is Coulomb's constant K times charge 1 times charge 2 over distance squared. So K is always 9 times 10 to the ninth. Technically, it's like 8.99, but this is going to get us as close as we need. Newton meters squared per Coulomb squared. Charge 1, 8.01 times 10 to the negative 19th. And charge 2, 6.41 times 10 to the, and I'm writing it shorthand because I'm lazy. It's more efficient. Not lazy, I'm efficient. That's right. All that is over the distance squared, 629 times 10 to the negative 10th meters, 6.29 times 10 to the negative 10th meters. Why do I write it twice? So I don't forget to square it. Okay, now we crunch the numbers. I'm going to do all the numbers out front in red and then pick a different color for the exponents. I like to separate these. I think the math is easier when I do. 1 times 6.4, all of that over 6.29 times 6.29. All right, and that is times 10 to the 9th and 10 to the negative 19th and 10 to the negative 19th, all over 10 to the negative 10th, 10 to the negative 10th. Each time I'm just looking through for the exponents, and it's all multiplication, so I can switch it around no problemo. All right, calculator. Here we go. 9 times 8.01 times 6.4 gives me 461.376. I try not to round in the middle whenever possible, only at the end. 6.29 times 6.29. 39.5641. 39.5641 times 10 to the. Anytime we're multiplying exponents, we're going to add those up. So basically 9 plus a negative 19 plus a negative 19. So subtracting 19 both times. 10 to the negative 29th all over 10 to the negative 10th times, or adding a negative 10 again, so it's negative 20th. All right, moving right along. Since I'm still in this color, I'll stay times 10 to the, let's see, negative 29 minus a negative 29, or subtracting, so on a minus 20, that's negative also, which really means we're adding it, so we get 10 to the negative 9th. To make sure I did that all right. And last but not least, I got to do some division, but I kept all the numbers. So 461.376 divided by 39.5641 gives me, boom, 11.66, blah, 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 times 10 to the negative 9th. Now, this isn't proper scientific notation because there's not, one digit in front. You can move it now if you want, but honestly, you've done the physics. So I'm going to put it in as is because that's still a number. No judgment. Number is still valid. 11.66 times 10 to the negative 9th. Bam. And actually, it adjusts it for you. So no big there. And this is force, so that's in newtons. Cool. So that's what we're doing. Again, K is always the same. As far as we can tell in this universe, K is the same, Coulomb's constant, to convert meters and coulombs to newtons. The charges you're getting from how many excess electrons, so that number times the charge on an electron, and the radius is given usually in the problem. And everything is based on this equation. The other versions of these problems basically give you similar stuff, but now you don't know one of the charges. So you fill in all the rest, solve for Q2. Or you're looking at and trying to find the distance. So you fill in all the rest and then find the distance.